Hello everyone. So today we are going to solve this lead code problem. And what is it says that we have been given a root of a binary tree and the level of the root is 1. Okay. So it starts from the level 1. Okay. So and the level of the children is 2 and so on. So we have to return the smallest level x such that the sum of all the values of node is maximum. What does it means that at each node we have to find the sum? Suppose for the first level we have the sum as 1, for the second it's 7 plus 0 which is 7, for the third level it's 7 plus minus 8 which is minus 1. So what we have to do, we have to find the sum of all this and return the sum which has the highest sum. In our case, it is level 2. And similarly, this is level 1 and this is level 3. So we'll return this level 2. Okay, so how we'll solve this problem? Let's see that. And also this is given in form of binary tree. So suppose this is our array which has given 1, 7, 0, 7, minus 8, null and null. So 1 would be root, 7 and 0 would be child of 1, 7 and minus 8 would be child of the left child, and null will be the child of right child. So we can solve this problem using BFS and DFS. So first we'll see how we'll solve using BFS. To solve using BFS, we can solve it using queue data structure. And later we'll see how we solve using DFS. So we'll deep dive into these two approaches, and both of the approaches have different pros and cons, but the time complexity is approximately same. So let's see the BFS first. So we'll use the queue data structure. We'll push the root node as the queue. Then we'll run a for each level. We'll return the sum and sum of the level, and also if the sum is greater than the previous sum, then we'll update that value in the sum. Okay, so and finally what we'll have, we'll also contain that previous sum level within our level, and we'll return that level value as a result. It would be in O of n approach. Now let's see how we'll solve this problem using DFS. We'll solve this problem using DFS using map data structure. Okay, in which we'll deep dive into the nodes and we'll store each value. So we'll use a method. Suppose we'll use our DFS method. We'll put their root comma 1 and store the level and sum of in a map. Like we'll store the level comma sum in each level and traverse the map to find the maximum level which has the maximum sum of the elements, that is sum of the nodes. Okay, so first let's see how we'll write the code in the BFS. Okay, so first we'll write initialize this variable which is max sum. Its value would be int of minimum, which cause we'll have the negative values as well. Then we'll define the variable which is result level, and this will contains our the final result which we have to return, which is a resultant level. Then we'll initialize the variable which is current level, which we'll have as 1 because our levels are from 1 to n. Okay, then we'll define a queue of tree node type and we'll name it as QUE. Okay, so we'll push our root node in the queue, this queue data structure. Then what we'll do, we'll run a while loop which will run until our queue would have been empty. Okay. So what we'll do inside our while loop, suppose we'll initialize an element which will give us the size of the queue. Then we'll have a int sum which we'll initialize as currently 0. Then we'll run a while loop where n minus minus till the size becomes 0. Okay. And inside this while, what we'll do, have uh, we'll define another variable of tree node time, which is which will have the first element of the queue. First element initially was root, so it will contain the root initially, and we'll pop that element from the queue so that the next element would be the left node of the root, and we'll put the value of that node in the sum. So it will have, firstly, the value would be root. Okay. And if our node of then what we'll do, we'll put the left node and right node, children of the root, left and right in the queue for the next step. Okay. This was the root, and we here we what we have done, we have put the left child in the queue data structure for the next step. Okay. And similarly we'll do with the right child as well. Here, if node of right, uh, then we'll push the right child in the queue data structure for the next step. Node of right. Now if our sum is greater than max sum, which initially would be, because our maximum is initially min int of min, which is the minimum negative integer, then our max sum would be equal to the sum. We'll update the maximum value as the sum, and also we'll update the result level as the current level. Okay. Result level equal to current level, and at last we'll update the current level and close this while loop, and after that we'll return our result level. This result level would be containing the final level, which would have the highest sum of the nodes. Now let's see our DFS code as well. Let me change the color of the pen. Okay. So we'll solve this using map data structure. We'll define as int comma int. First would be the level and second would contain the sum. While, and we'll define a method which is void dfs, and we'll pass the root and the level, the tree node and the level. Here, tree node and current level. Okay. And if our root is null, then simply we'll return the from the loop. Okay, and return. Okay. Then we'll define map current level, which was the first level, as plus plus. Okay. And root is root value. Okay. Current value will contain the root value. And then what we'll again call this loop by sending the root, left child and the current level plus 1, and we'll again call this loop by sending the root, right child and current level plus 1. Okay, so in here we'll call this function again and again, and at last our map would be containing all the levels and their corresponding sums. Okay. Now we'll see how our main method would look like. In our main method, we'll call our DFS by sending the root node and 1 initially. Then we'll define a variable which is maxsum equal to int min, as our node squared have negative values as well. And then we'll define a result which is 0 to contain the result level. Okay. Then we'll iterate through the map for auto IT of map. Okay. And inside it, we'll define a variable to contain level which is IT of first, and then we'll contain the sum of that level in another variable named as sum, which will contain IT of second. And then we'll check if our sum is greater than maximum. Basically what we are doing here, we are finding the level which is having the maximum sum. Then we'll update our maximum is equals to sum and our result is equals to level. And at last our result would contain the level which would have the maximum sum of nodes at that particular level, and we'll return that level which would have the maximum sum. So that's how we have seen it by BFS and with the help of DFS. If you have any doubts, just put in the comment section, and I'll try to reply each of one of you, and try to solve the daily lead code problem with the I'm also uploading the daily videos, and keep learning, keep exploring, keep growing. Bye bye.